Have you ever looked at a giant cargo ship crossing the ocean and wondered why its engine never seems to stop? Every single day, thousands of massive vessels carry almost everything we use: phones, cars, clothes, food across the world's oceans. Hidden deep inside each ship is an engine as tall as a 4-story building, producing more power than dozens of sports cars combined. But here's the strange part. Even when a ship slows down, waits offshore, or appears to be doing absolutely nothing, that enormous engine often keeps running. At first, it sounds like a terrible waste of fuel. So why would shipping companies spend thousands of dollars every day instead of simply switching the engine off? The answer isn't just about fuel. It's about engineering, economics, and survival. Let's go below deck. Inside the engine room, everything feels oversized. The ceilings stretch several stories high. Metal walkways wrap around gigantic machinery, and standing in the center is the ship's beating heart, the main diesel engine. Unlike a car engine spinning thousands of times every minute, this giant turns surprisingly slowly. Most large marine engines rotate at only around 100 revolutions per minute. But don't let that fool you. Every single rotation pushes a vessel weighing more than 100,000 tons through the ocean. And that's exactly why stopping it isn't as simple as turning a key. One of the biggest reasons is the fuel itself. Cargo ships don't usually burn the clean diesel found at gas stations. Instead, many operate on heavy fuel oil, a thick, black substance left behind after gasoline, diesel, and jet fuel are refined from crude oil. At room temperature, this fuel is almost solid. It won't even flow properly through the pipes. Before the engine can burn it, the fuel must be heated continuously until it becomes thin enough to pump and inject into the cylinders. That means the entire fuel system depends on constant heat. If that heat disappears for too long, the fuel begins to thicken, clogging pipes, filters, and pumps. Restarting everything isn't a matter of minutes. It can take hours. Then comes another challenge. You can't start one of these engines like your family car. There is no giant electric starter capable of turning a crankshaft weighing hundreds of tons. Instead, cargo ships use high-pressure compressed air. Powerful blasts of air force the pistons to move until the engine reaches enough speed to ignite its own fuel. But there's a catch. The ship only stores a limited supply of starting air. If several restart attempts fail because the engine is cold or conditions are difficult, the crew must wait while compressors slowly refill the air tanks. Far from land, that's the last situation anyone wants. Stopping the engine also creates another invisible problem. Metal expands when it's hot and contracts when it cools. Marine engines are designed to operate at stable temperatures for days or even weeks. Repeated cooling and reheating creates thermal stress inside massive steel components. Over time, that stress increases wear on cylinder liners, pistons, bearings, and other expensive parts. Replacing just one major component can cost tens of thousands of dollars, not including the time the ship spends out of service. Suddenly, the fuel saved by shutting down the engine doesn't look like much of a bargain. But fuel and maintenance aren't the biggest concern. Time is. Every cargo ship follows a carefully planned schedule. Ports assign arrival windows. Cranes, trucks, warehouses, and railway systems are all waiting. If a ship arrives late, it may lose its docking slot and wait hours or even days for another opening. That delay affects every company expecting the cargo. One missed schedule can ripple across an entire supply chain. Compared to those losses, keeping the engine running is actually the cheaper option. There's also a reason that has nothing to do with money. Safety. Out in the open ocean, a moving ship remains under the captain's control. The rudder works because water flows past it. Without propulsion, the ship quickly loses maneuverability. In rough weather, that's extremely dangerous. Strong winds and powerful waves can turn the vessel sideways, making it much harder to control and placing enormous stress on the hull. Keeping the engine ready means the crew can react immediately if conditions change. Sometimes, those few seconds make all the difference. Does this mean cargo ship engines never stop? Not at all. When a vessel reaches port for unloading, maintenance, or repairs, the main engine is shut down in a controlled environment. Smaller auxiliary generators continue supplying electricity, while engineers safely maintain the fuel system and prepare for the next voyage.